Nice to meet everybody. Um, excuse me. So I'm Mike Stephenson. I'm a local guy, so I live down near Cobalt, Silverlink Way. Um, I've worked in the Microsoft space for many years. So I've been a Microsoft MVP for about 16 years now. Um, and I first started working with Azure when it was first in preview. So I was the tech lead for one of the big early adopters in the UK, and I've kind of worked with it ever since. And one of my favorite areas to talk about is Azure Integration Services. So this talk's going to be talking about the relationship between Azure AI and Azure Integration Services. And really, I guess the background a little bit is an event I was at a couple of weeks ago. Microsoft had this really interesting statistic where they were saying 70% of the AI projects never make it to production, which I think is quite interesting. And I think for me, probably what's happening is a combination of things like we build a project, but we don't really know what we're trying to do. We don't really know how to make it into our real world scenario. And these play projects, they don't deliver the value that customers need. And one of the things that I've felt for a while is Microsoft talks a lot about the relationship between the data platform, so things like Fabric and AI. And I think one of the big tricks they were missing was talking about how integration is really important to AI use cases. And I think with that, what I was hoping to do is really kind of show people what Azure Integration Services brings to the table to help you level up your AI projects and deliver more. And I think that hopefully would be really cool for everybody in the room. And my hope is you take some ideas back to the office. You can maybe quickly develop something that brings real value. You can show to your business that you might then invest in doing a real project with. I guess a little bit about me. So in addition to integration, I also talk a lot about Azure cost management. So in the past, at one of the user groups, I talked about FinOps and how to save money and stuff. I also I work for an ISV called Turbo 360 who build solutions to help you manage Microsoft Azure solutions. So if you're looking to sort of make it simpler to manage the solution you build, whether it be a .NET solution you deploy in Azure or something else, you might find them interesting. And then I also do a lot on YouTube. So if you're looking at questions like, how do I decide which is the right technology to solve for a given problem? I've got some pretty popular videos where we do things like, data factory versus logic apps, function apps versus APIM, and kind of looking at, deep dives on what these questions really are about. Now, in the agenda, we're going to cover three probable areas. We're going to talk a bit about app modernization. We're going to talk about agentic AI workflow, and then we're going to touch a bit on MCP at the end. I'm going to talk about agents as well within this, and I'm going to combine a few demos, a few architecture slides, and really what I want to do is kind of hopefully just demystify things, because I feel like, in fact, I think this slide here really is a good one for me. I've been feeling like I struggle to keep on top of everything these days. We've got in the integration space, that box up at the top's all the different technologies that I have to think about. Where do I use what? How do I use them? And then, kind of this year at the summit I was just at recently, Microsoft are talking about integration, and they, effectively they've chucked all these other technologies on that are now in my ecosystem, and it's just so confusing. So I'm hoping to kind of make that a bit simpler. I think I'm going to be really quick on this slide here, just because I want to make sure I don't eat into any of Mark's time. But there's been a bit of a journey with AI so far. So if you think, 2022, we were really talking about ChatGPT. I remember at this event we were at, nobody was talking about, that's literally a couple of years ago. Nobody's talking about AI at this event we were at. And I sort of, at first someone showed me ChatGPT, and then I kind of knocked up this little demo in the break between sessions, and I was showing one of the other MVPs. I was like, how cool is this? And then suddenly the next year, the whole event's just about AI, and it's just kind of gone crazy, and it's hard to keep up, is where I want to kind of hopefully help everybody a bit. So this for me is really the Uber level journey that we've been through the last few years, where things Microsoft are talking about for AI. Now, if I think of the integration space, one of the really common scenarios you might see with integration, let's imagine we've got something like a third party over here submits PDFs to us, and we've gone beyond OCR solutions now. And what you might do is have logic apps process these, but you've got things like document intelligence can sort of look at the document you've been sent. There's models that specialize in certain types of document, can extract the data out and make it easier to build these kind of solutions. This is very much a classic reference architecture you would see in the integration space. But really what I want to get into is we can go so much further than that. There's so much more we can do. And that's really what I want to cover in this talk. So the first demo we're going to do is how do app modernization. So how can we take an existing application that we've got, maybe it's written in .NET, maybe it's written in some other language, but we need to make it AI enabled. And this is the first place I think Azure Integration can help you. So I'm going to introduce you to Bob the Builder now. So we're going to jump into our first demo. And what I kind of wanted to do here was I wanted to think what's the most ridiculous application that I can AI enable with Azure Integration Services to show you guys what this would look like. So right, so we're going to integrate AI into Minecraft, and we're going to build a bot that'll help us build stuff, because I'm really rubbish at Minecraft and I want to show you guys what this would look like. So what we're going to do, I'm just going to find a bit of space. So we're going to use what's called an advanced computer. So this is actually a modded version of Minecraft. So it's called Computer Craft. So we've got some extra widgets in it and stuff like that. And what I'm going to do here is I'm going to put a computer, and this one's called Eddie the Builder. So we can give it a name. And what we're going to do is we're going to teach him how to use AI. But obviously in the game, we can't do AI directly in the game. So we're going to use Azure Integration Services to connect to an AI, and we're going to let him learn some stuff on how to build. So what I need to do, the first thing I need to do is I need to give him some bricks. So we'll give him some wood. Right, so we're going to go in and we're going to load him up with some wood. And then in Computer Craft, this is his operating system. So I can create a file here by just using, we'll do edit a file, and then I'm going to basically save it and exit. Right, so he's now sat there. He's got some inventory in him. Now, what I need to do is I'm actually going to jump out into VS Code here. So under the hood in this game of Minecraft, there's actually loads of files behind the scenes. And if you notice here, all these different folders, that's all the different computers in the game. So I'm going to actually load some code into him. So I've just got a little PowerShell script that copies a bunch of code into that computer. We're going to have a look at this again in a few minutes. So if you just bear with me on this. So what I can do now is I can come back to Eddie the Builder here. So I can now execute some commands. So he's got this command I've written called wait for command. And he's listening on port 11, which is his port number. So if you imagine these computers can talk to each other in the game, and he's listening on port 11. Just going to set the time there because I think it's going dark. Right, so I'm now Steve, and I've got an advanced pocket computer, so I've got a tablet in the game. And what I can do is I can basically talk to my little bot. So what I'm going to do is I'm going to use the send command button, and we've got bot number 11, and I need to send a command to him. So the command I've got is called build me. Sorry, just a second. I'm not sure if it's case sensitive. So I need something to ask him to build. So I need a volunteer at this point to give us a prompt that we're going to send to the AI. Now, just the caveat: we've only got 64 blocks, so I can't build you a city. But does anyone want to volunteer something? Tower, castle, a huge tree trunk. Okay. Yeah. Actually, do you mind if we pinch Quasim's there? Treehouse. So the reason I say that is so reality check here. It's not as good as what you'd hope it would be at building stuff. But he can definitely build towers 1 block high, and that's what it'll probably do. But a tree house will be quite cool. Tree. Right, so I've sent that command. Now we should be able to go onto Eddie the Builder, and you can see if anyone kind of recognizes that there's actually a URL for API management. So he made a call out to API management, and you can see he's actually gone off doing his thing here. So this is where we cross our fingers and hope he builds something useful. While he's doing that, he kind of has a habit of like exploring his environment first. But one of the ones that I did that's quite cool is I've got a YouTube video that I haven't released yet, but I've recorded where I've actually got this demo able to call different models behind the scenes. So I can call DeepSeek and a couple of others. And so the video actually did a comparison to see who could build the best house, and none of them built anything that looked like a house. But it's a bit of fun, that's the key thing. So here we'll just grow up, and I mean, I can see what he's kind of thinking a little bit. Maybe he's trying to build a square, might turn into a treehouse. I think he might have stopped from the looks of it. Now you get the point here. We can command him to build something, but what I want to do is show you a couple of things here. So before we have a look at the code, I want to kind of show you what's really going on here. So me as Steve, I've sent a message to my bot. My bot calls out to Azure API management, which forwards it to a logic app, and that calls onto my Open AI model in Azure. And that basically gets the prompt. It then does some stuff, gets a code snippet that it's going to return back to my bot down here, and then he's going to try and build something that I've asked it for. So we've really, through app modernization, we've AI enabled Minecraft in, 7-8-year-old Minecraft Java edition can now do AI. So let's have a little bit of a look here. If we go back to VS Code, so I think he was number 11 was his computer. So what I've actually done is there's a few files that when I ran that PowerShell script before that get copied into the right folder. So really I've got this bit of code here that actually does the call out to API management, waits for the response, and basically what it does is it puts this file here in the folder and then it dynamically executes it. So here's the code that actually came back from the model. So you can see it's commanding the turtle to move forward, turn, place blocks, etc., etc. And then it just ran it. Now, what was quite interesting when I compared the models, if I remember right, DeepSeek built the best thing that remotely looked like a house, but had the worst looking code that was the hardest to read. Azure Open AI was nicely functions that it was calling to reuse stuff and that kind of thing. Much nicer code, but it was by far the worst house. And I think what actually on Quasim's prompt there, one of the interesting ones, the last time I did this demo, one of the guys said, I want build me something to protect me from zombies. And we were like looking at it, and it was building this like steps thing, and we were like, okay, it's just gone off on one again. But apparently, somebody was saying their daughter said that apparently zombies can't climb stairs very well, so it actually probably thought of a better solution than we did because it built something higher up that it wouldn't get to, which is quite interesting. So I better show you how we make this happen then. So really, behind the scenes in this demo, what I really end up with is this logic app here is what got called. So here, you can see we've got a few steps that we go through, but the key one's this HTTP call. So I've, a few of these steps in the logic app are me just like doing other things in the demo that are out of the scope of today. But the key one is I've got this call here over HTTP. There are some connectors for this nowadays, actually, so you can also use some of the built-in connectors that have come in a bit since I originally did the demo. But you can see we just have the prompt and the description for the, the system roles, description of what you want the model to do, the user prompt, and then that'll generate and return it. So actually, in reality, the logic app piece of this is actually really simple, and it can get up and running. And from the perspective of everybody going back home, it's just an API call. You're doing API calls in your applications all day, every day. So you can plug the right API into the right use case, suddenly you can leverage that model potentially. Does anybody have any questions on that before I jump on to the next bit? Um, yeah, so actually it just does most of it for you. So all I actually did was put a good system prompt in to tell it what you really want. There's a bit of an art to writing that prompt, which really means my user prompt can be a lot more generic. And then for some of the models, like in the system prompt, I would do things like, don't give me any descriptive nonsense telling me what it's doing, which it quite often would do. So I would say, just give me the raw code. And sometimes it'll put, I can't remember the name of the character, but the little 3 characters you put in a markdown file to wrap around a code snippet. So I just chop them out in the logic app. The logic app's actually the perfect place to do that, which is, again, it would be a bit awkward to do that in API management. So logic app with API management gives me a bit of code to manipulate. So in my real demo, when I do the different models, you'll notice here I've actually got I don't know whether you can quite see them, but I've got a logic app for Azure Open AI and a different one for DeepSeek, because they're very subtly different. And I just sit like a controller on top of them that decides which one to use. Maybe. Yeah. I mean, so I do a little bit like that actually in one of the other demos and a little bit, but you can tell it, like, you could tell it to return C# code, for example. You could tell it to return JSON with some data in. So one of the other demos, I need to generate test data. I couldn't be bothered to knock up all the test data, so I just wrote a wrapper logic app that called the AI and said, create me a dummy order, give me it back in this format. Here's an example, and it just does it for me, and I'd just kind of encapsulate that. Okay, so next up we've got, if you think we've done the first thing, which is we can just now plug a model into our application where you may not have thought you could do it before. But Microsoft have started talking a lot about agents, and I've got a bit of a video that deeper dives into some of this if anybody wants to learn a bit more. But we need to think about what really is an agent, and this is where things start getting quite confusing. So really, we've got things like the inputs, the system messages. Sorry, did somebody have a question there? No. So the agent itself is really like a construct around the LLM, the instruction of them, and then we've got these things called tools that have started coming around like recently as well. So the tools is really how you can plug things into the model. And this really makes the model much more powerful, and you can dynamically plug stuff in. So what this allows you to do is you can do things like here where you can plug in things like fabric, things like search. So these would really be called knowledge, but then you can plug in other tools which would be things like functions and logic apps. So you can kind of build your model where it knows all this custom data that might be in your organization, and you can build actions that the model can now start executing. So really, we're kind of going from a model being just a conversational, tell me something interesting. You can make it able to dynamically look stuff up, and you can make it easy for it to actually execute an action, which really takes it into a more, takes it to the next level. So a couple of examples here. So this is a screenshot from AI Foundry, and this is where when you start looking at agents in AI Foundry, this is where you would plug the knowledge in. So you might plug in like SharePoint or storage or search or something, and this is where you'd plug the actions in. where you might plug in like a function or a logic app. But really, at this point, one of the challenges here is that all of these things are this side of the model. They're away from the user over here. And one of the things that some of the other options that we're going to talk about in a minute are, if I can actually move some of the tools to this side, I can be more aware of the context of the user. So for example, if you imagine I call the model and I say, here's some input data, you've only really got that input data and external stuff to work with. But if I can do a callback, I can actually access the state that you've got over here to kind of do some interesting use cases with. So we're going to start looking into that a little bit as we go into custom agents. So is anybody, just to level set here, is anybody familiar with semantic kernel before? Played around with it? Awesome. Yeah, champion. So really, semantic kernel is like a framework that you can use in .NET if you're writing your own custom application. So what I'd be doing here is I'd build a custom app. I've got my code. I use the semantic kernel framework, and then that lets me call onto a model and ask some questions. But I can register my own classes here as what they call plugins. So there's a couple of things terminology-wise that I find confusing here. So when we talk about tools, some of the different implementations call these slightly different things. But in this case, semantic kernel is really referring to a plugin. So what would happen is my call goes from the user through my app to the model, but the model's aware of my plugins, and he can call back to my application and have my app do something that returns data back to the model that then might be part of my response to the user. Now, what's really great about semantic kernel is it's really easy to kind of implement this stuff. So here's a code snippet where I'm actually registering my plugin, where I'm passing in my lights plugin, which is actually this class over here. And really all you're doing is you're building a .NET class, decorate it with some attributes, make sure it gets loaded into your dependency injection. And then basically the model's going to pass a callback to make it execute your code when it finds the right need to execute your tool. That actually becomes really powerful. So a good example of one of the things I did is I wrote a WhatsApp-like interface where I can chat with my .NET app, and I can have all these plugins firing, going and querying data from my database or calling out the users or something like that. And you can start doing some really cool stuff here, but you can really get the model to interact back with you, which is the key bit. Now, what's quite cool is if we start thinking, right, .NET code's great, but sometimes we like higher abstractions to kind of make it simpler and get rid of some of this boilerplate code. And function apps have this this bit they call Open AI assistance, and they've got some bindings. I think they'll probably change some of the namings of this, because I think this has been around a while, and I think it's changed a bit since then. So these names might change, but basically I call my function app, and my function app's going to register the skills with the model. So when my prompt hits the model, it calls back to my function app, executes my what it calls assistants in this case, but they're really the same as a plugin, same as a tool. And it means my model can dynamically execute things in my function to help me. What's really cool about this is it starts like encapsulating the service a bit. So before, with semantic kernel, the model piece was really a part of my bigger application, so I'm taking on all the complexity of the app. But here with the function app, I can kind of really create like a microservice idea where I can build an API with just some really small components to build a service on top of my model. And again, same as before, we've got our function down here where I've just registered it as like an assistant trigger that'll basically get fired by the model when I need it to fire it. So it's, again, very declarative programming model that we can add extensibility to the AI. Okay, so that's kind of building up to this bit that I really want to talk about, because this for me is where it really starts getting quite cool and interesting. So quite recently, Logic Apps announced AI agent loops, which I think is really, really cool. So here we've got an example, and I think actually, so this is an example of a typical logic app. It's a very deterministic workflow. I've got a really sort of predefined sequence of steps. It's really great in a way where, I've got an expected set of things that'll happen, which is good for most orchestration type workflows. But the problem with this is in the modern world, we're building more dynamic solutions, and sometimes we have the need for a non-deterministic workflow. So it might be something like we've got unstructured data, we've got logic that needs to be very dynamic based on achieving a goal, but we don't necessarily know the steps that we're going to take to get to that goal. And that's where combining the logic app workflow plus an AI model really kind of moves us big time towards this. And hopefully we can show a good example of this in action. So if I go over here, so really here, for anyone who's not familiar, this is Logic Apps Standard. And the AI agent loop's only available in Logic Apps Standard. So I don't know how much people know about Logic Apps versus, so you've got like two models. You've got like a pay per execute consumption model, and then you've got a pay per minute per hour sort of host based model. So this is the second one. And what we've really got here is we've got this thing. Actually, I'm just going to go around here to show. So we've got this thing here where we do an evaluate customer order. So what I'm really doing is I'm passing in this customer order. Now imagine I've built a service where we received orders in different formats. So coming back to your bit about JSON before, imagine, I'm building this experimentary service, and some people send me an order in a lovely JSON format. Some people send me like a horrific EDI file or something like that. How do we build all the different ways of processing it? So what we could do is we could call the agent here. That'll send it out to the model, and I'll show you the prompt in a minute. But what will happen is that based on the instructions, the model will dynamically call back. Forgetting I can't write here. Dynamically call back and execute these tools. So it might say, I think in my case, my instruction is if it's a high value order, send a notification to the VIP team. So it's going to look and say, right, well, I've got the order. I need to get the customer. I need to get their value and maybe their last order. And then I'll make a decision of whether it's high value or not. But we haven't defined any criteria because we don't know what the criteria is. So it might decide, the customer's last order was messed up. We might make them a VIP, or the last order they made was really high. Let's make them a VIP. So it's going to make that decision for us. And then if it needs to, it'll send an email to the VIP team. Now, if you think in the business world, right, a human's going to make that decision based on instinct, and they're going to make it based on experience. And you can't do that in a deterministic workflow. You need pre-baked, hard-coded proper rules to make the decision on. Whereas here we can behave more like the human. So if I look at an example of one that executed. Sorry, I've gone at the wrong bit. So if we look at this one that executed yesterday, right? So what happened here is my order came in. So I can show you that, one of the great things about Logic Apps, you've got the run history if nobody's familiar. So imagine my order was sent in over HTTP, triggered the Logic app, and I can see, in this case, this is what the order looked like. Now, I haven't got anything in this Logic app that defines what that JSON structure is. I could do that if I wanted. I could have a well-structured format, but actually you can send any data to this. And what happens down here is in my model, I've specified, actually I'm going to just show you the designer for this, just so I think it'll help. Right, so in here, so this is the bit we were talking about before, I think in your previous question about the prompt. So this is a proper action that calls the AI model. So I've put some config in for it, but I've given it some good instructions here. So I've said, right, you're a sales and processing agent. I want you to evaluate the orders received, decide if they're a VIP or not. I've told it a little bit about the things I expect it to do, and then you'll notice down here, I've basically said, please evaluate this order, and just passed in whatever message you send me. Now, it'll then go and basically call the model, and what I can see in the run history, here's the bit where the data we actually send to the model itself. But what's quite cool is this agent chat kind of shows me what the model did. So you can see, that's the system prompt right at the top. The little blue bit kind of next down is like the data that actually came in. And then as we go further down, you can see it executed my tools. So where those little hyperlinks are, that's the bit where it called to the tool, and I can click them to jump to the tool and see more, and we can see that in a second. And then it gives me down here the details about why it made the decision. So let's have a quick look at what it said. So, we've got the details of the customer. The customer's account was premium and active. We've got the last order, the loyalty points, etc. But it said the orders is above the customer's threshold. The customer has a premium. There are no negative status indicators. I need to scroll it down. But it said, while this is a high value customer, the order amount's quite low, so we're going to decide not to send it to the VIP team and just send it straight through. So that would be, if you think about how you would code that logic yourself, that's going to be quite complicated. Loads of edge cases to think about, and you're going to have loads of bugs in that. Whereas here, that there, just offloading all of that to the AI model is a brilliant use case to really leverage the model for edge cases, for unpredictable scenarios. And really, the workflow itself just adds all of the benefits the Logic app brings to the table on top of the model. Do you guys have any questions on that before I move on to the next little bit at all? Does that come across pretty clear about how that looks? Good, okay. That's the point. Yeah. No, that's exactly the point. So if you need 100% predictable, reliable stuff, you need a deterministic workflow where you build the logic for you. Where you've got the unknown, the unpredictable, don't know what to do. So if you imagine in my case, if I had, let's imagine I've got 100 partners send me orders, and like my 10 big partners have well-defined, well-structured messages. I might build a deterministic workflow for them, but I might be onboarding new partners every month, and I don't know what to do with them, and it would take me months to build stuff. So that would be where a deterministic workflow could help you, because instead of manually having somebody key every order, if I can get maybe 80% of them processed with the AI giving me a hand, and then I just offload to the VIP team those ones that I need to, I can kind of just get much more return on my investment and have the AI take some of that load that I would have to do by hand myself. It's 100% not going to be perfect, but that's not the use case it's intended for, is the key thing. And that's where I think the kind of the heart of a lot of the stuff I talk about is about picking the right tool for the right choice. And I think one of the great things I saw Microsoft say at the event I was at a couple of weeks ago, everybody at Microsoft at the minute's really all 100% AI solves every problem, but the guys were saying, actually, make sure you pick the right problem for the right AI solution, and make sure if you have a requirement set that doesn't meet AI, you've got the other tools here anyway to solve those problems. But that's probably, if you think of that 70% of AI projects don't make it to production, that's probably one of the contributing factors in there, that they've had a need that wouldn't be a great fit for AI, and they've chosen to try and AI it by mistake. But I think, for me, what's great here is I could, I literally knocked this demo up last night in an hour. So if you can do something similar to that, you spend half a day, you prove, number one, fail fast if the idea doesn't work, you can get out quick, but you might find you can really quickly help, if I can free up 2 or 3 people from the team, by automating some of these orders, then I've got a lot of things I can do with that time I've freed up that might help the business a lot. But, yeah, 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 100%. That's the position we're in with AI. So I think what I would expect there is companies will hold back really critical high risk decisions right now and not do that if it's beyond their comfort zone. But I think what you'll find is as the models evolve and become more predictable, you have more models that are more specialized and they'll learn, you know what I mean? So I think they'll get better over time, and that's where the risk attitude will be more aggressive. Well, I think in my demo here, the idea is the VIP team. If I sent them every order, they wouldn't have the bandwidth. So if I can send them just the right orders, and I think a good example with that case is I can instruct the model with a system message where I could have said anything for any customer who's got a high value sent to the VIP team. But actually, in this case, the idea was we've got a high value customer, but the order value is really low and they've got a positive track record. Let's not send that to the VIP team and we can better use their bandwidth on something else. And that's the bit where I think that kind of logic would be very difficult to maintain and code. Okay, I think this might be a good scenario on your question as well. So really the difference between agentic AI and workflow, which is what that was really about, was more goal orientated, such as onboarding a customer, the continuous learning, managing dynamic complexity, and then you've got AI agents, which are much more task orientated. So something like add a customer to CRM. If I can, give somebody a chatbot to basically tell me about a customer and have the agent just add them, could be a good AI agent scenario. Okay, so so my talk's really about Azure integration as well. So what did Logic Apps bring to the table in that scenario? So there was a couple of really good things it did for us. So number one, that run history is really powerful. So I think was it your question was about the accountability of the question. So in the Logic app, you could see in that run history, I was able to show you, here's what happened, here's why it made the decision, and I can, tune things if I need to, but at least I know what happened. That's something that Logic app gives you. That some of the other choices like semantic kernel or functions, you're really going to be rolling your own stuff to a degree for a lot of that kind of thing. The In Logic apps as well, you have a lot of connectors available. So here where I'm looking at these bits here, what I'm actually doing is the tool fires and I just call another Logic app and encapsulate some logic to do something in there. So imagine when I go get last order, that child Logic app goes and calls the CRM system and then it might call SAP, and I've just kind of encapsulated that logic that I can reuse. So that's quite a powerful thing to be able to use the connectors and Logic apps for all the different systems. We have durability in the workflow. So if something goes offline, there's retry support. It'll pick up processing later. You have manual retry as well. So if does a number of automated retries fails, you can resume it from where it got up to. You've got parallel processing at scale, burst scale support. So if me doing one order now is one thing, but what happens if I've got 1,000 orders in the next 5 minutes and then no orders for the next 2 hours or something? You can handle that kind of support with processing. You've got a lot of the security, observability, VNet connectivity. And the point was that all the things Logic apps already have are there to help you do that AI solution as well. So what we've really talked through in the last few slides is really the abstraction going this way here. So at the lowest level, we had my custom code. Functions made it a bit easier because we abstracted some of the plumbing. Logic apps made it a bit easier again because we had all the designer support, low code support, and so on. Yeah, it's kind of like a. So if you think C sharp code that you write yourself, functions kind of gives you a framework for building a serverless type function that can execute on either a prepaid plan or a per execute model. So it's really a specific way of writing your C sharp that'll fit into the Azure functions model. If you did that, you would be back to the custom coded app. So that app could be an ASP.NET web app. I think the question I would have in my architect's head would be, would you want to write that semantic kernel within the application, but you could encapsulate it in a function, for example, just call out from your app with an API call to the function and kind of do it like that. It might be a nice way of separating concerns there, that you can make that model reusable as a function. How are we doing time wise? Right, so I'll start trying to wrap up in a second. This touches on one of the questions from before. So when do we use an agent, when not to? So the agent's great if we've got unstructured data, we've got things like conversational use cases, human-like decisions, loads of complexity, and we've got loads of edge cases that would take us forever to code for. The workflow approach, the typical workflow works really well if we've got industry standards, we've got very repeatable, reliable scenarios. Performance is a big one. So AIs take time to respond. So if you've got low latency requirements or high throughput requirements, anytime you add a model is going to add loads of overhead to that. So you need to factor that into your thinking as well. And also payload size is going to really matter for models. So a model, the costing and the throttling's based on tokens, which is really about how much data you're sending backwards and forwards. So if you're going to send a really big message to it, you're going to find that that's going to be affected by using a model. So you might prefer the traditional workflow approach. Now, what's next is kind of the next bit. So really, we're now coming on to MCP. So how many people have come across MCP so far? Awesome. Oh, that's brilliant. Brilliant. So I'm not going to try and teach you guys anything new about this, but really, for anybody who's not, so MCP is really like a protocol to make it easier for models to communicate. And if you think of it as basically like an API definition for communicating between models and some standardization here. And a good example of what this might look like is, in my integration scenario here, I can build what we refer to as an MCP service. That's really like a service that I'm going to have a model call. And I can build these MCP servers. We can build them in API management. They could be done with functions. I think functions has just gone into preview, and logic apps is going to go into preview quite soon. And we can do different things. So a good example with API management is I might proxy a logic app that integrates to SAP, or I could make it call my logic app directly. And really, in the next bit is we've got this thing called an MCP host. That's really your application or some application that's hosting the model. So a good example of this would be something like Copilot or something like VS Code. Would be the application that's going to let you interact with the agent, and then it'll basically call your MCP services when you're going to use them. So I think a couple of little demos on that. So the first one probably won't work because it started having a bug on it last night, but here in VS Code, I think you guys can kind of see that okay. So what you can do is you can register an MCP server. So what I would do here, right, so I'm going to integrate with Octopus Energy because I want to know what my gas and electric usage is. So they've got a bunch of services I can use. I've written a logic app to interact with them. I've stuck an API management in front of it. And what I've got down here is somewhere I've got my Octopus API. So there we go, Octopus Energy API. And I've got two little operations in it called get electricity and get gas. And the bit in API management, so this is a preview, and you've got to put a special URL in to enable this. And the other thing is you have to have the basic tier of API management, so you can't use the developer tier, which is one of the things I didn't learn till the other day. So you have to actually pay a bit more to get this feature, but you can go and create a new MCP server, and I can basically pick my API. So if I pick this one, choose what operations I want to add to it. And really the idea is, and that's really how easy it is to set up, but the idea is API management acts as a proxy to an API that you've already built. So that's great because all of us in the room can probably build APIs. We're very used to it. We're really in our comfort zone. So now we can use APIM to just proxy those APIs, and we can now put them into an agent. So in VS Code, what I've done is I can do this command. So you'll see there's one here called MCP add server, and I can put the URL in for my API management. And what that really does is it creates this JSON file here, and you can see I've got my API registered. So that lets me use that in Copilot, GitHub Copilot, for example, in VS Code. So what I should be able to do down here is, I think so let's see if that works. I don't know whether it will. So what that's doing is I'm putting a prompt into, yeah, didn't like it. There's an interesting little bug here where it got an error, and it seems to remember it got an error, and it doesn't want to ever, even though I fixed the API, it doesn't seem to ever want to unremember that it was getting an error, so it doesn't actually make a call, which, again, preview tech, I guess, so it's a work in progress. But if you think about what that means, right, so now I'm in VS Code, I can build tools in my organization to plug into stuff, stick them in API management, and I can maybe enable my developers to do stuff direct from chat. So maybe I could say, have we got any support tickets? Tell me more info about support ticket 53, add a comment on it. We can just really automate some of ourselves at work. But also where that gets really cool is I can plug it into Copilot as well. So I used Copilot Studio here, and I've built myself the Octopus Energy bot. So hopefully this loads up nice and quick. So with the Octopus Energy bot, what I basically did is I didn't use the MCP bit because I think that bit isn't supported in Copilot Studio yet, but I just pointed the API directly. So I've given it some system prompts and stuff, and then in the tools bit here, you can see I've just linked to my Get Energy and Get Gas, plugged my API that calls Logic Apps, that calls Octopus straight into this bot. And then when I publish it over here, you can see I can go in and go, right, what was that, to 11. So that now, if you think about applications we're building, I don't know about you guys, but I'm the worst UI developer going. I don't need to do a UI anymore. I can just build some APIs and I can just plug them into a bot in Copilot. And like a good example here was I hadn't really used Copilot Studio before. Before, what day are we today? So before the weekend. I knew about it, but basically I had my Copilot bot connected to my API and usable in here in under an hour from never having used Copilot Studio before. So that's pretty powerful, that, when you think about the onboarding experience. We've got, here's a list by hour or by every 30 minutes of the energy use from my Octopus Energy. So if I can do that in a couple of hours, bit of investment, and think of the opportunities that are suddenly opened up with all the different, there's a few guys from the uni here. You want to build a bot that talks to sits and queries some data. If you plug it into your APIs, you can query the status of a student. You can let, students can go and query what their results are in a bot, and you can build bots for all these different things. So you could have like a what's my next lesson agent? Actually, I remember, Gerben, do you remember the one we did with the washing machines? We did a cool one a few years ago where the student accommodation had all the washing machines in them. We built a little power app where we could query the status, so I could sit upstairs, watch the TV, and I could query whether there was a washing machine nearly finished its load in the basement. So I know it's worth going downstairs to put my washing in or not. You could build something like that in no time with an agent in Copilot. That really, for me, is the power of the use case. Okay, so if we start wrapping up now, so that's what you can do today with MCP and API management logic, apps and functions. I think in a number of months' time, all those boxes will be green, and it'll be really cool, and you'll be able to do so much more. And I think that's pretty much it. So hopefully I've given you guys lots to think about. Some really great questions there. Feel free to chuck any more my way, but otherwise I'll hand over to Mark, and thank you for listening to me waffle.